having looked at how to write a chemical equation, using symbols. Remember, we started by writing the chemical equation where we only used the word equation, but now we want to write chemical equation. We have written chemical equation using now the symbols. We've written chemical equation using symbols. So we want to see how we can balance this chemical equation. Now, a correct chemical equation will have the correct chemical formula of the products and the reactants, and then it has to be balanced. That's when we say that we have a correct formula equation. Now, chemical equations are short. Remember, we have said that chemical formulas are short, clear, and accurate description of chemical reaction. A reaction process can be explained using an equation. For example, when oxygen reacts with magnesium ribbon, a white solid of magnesium oxide is formed. We have been using a word equation to describe such a reaction. We have been using word equation to describe such a reaction. But now, here we want to use now the symbols. Remember, at the beginning, in Form 1, we learned about the chemical symbols of different elements. Now, these symbols are the one we want to use to write the chemical equations. So we are saying that they are precise. They are just clear. They are clear. The chemical equations are clear. So a reaction process can be explained using an equation. Now we are saying, for example, when oxygen reacts with magnesium ribbon, a white solid of magnesium oxide is formed. We have been using a word equation to describe such a reaction. But now, after having seen how we can write it using the word, now we want to use the symbols to write such equation. Now, reaction process, you say that can be explained using an equation. So we are giving an example of a reaction between oxygen and magnesium ribbon. So we are saying magnesium reacting with oxygen to have magnesium oxide. Now we are saying that the positive sign here is not used to mean addition, but in chemistry it is used to mean reacts with. It is used to mean reacts with. Now the sign, the arrow sign after the reactants, the arrow sign after the reactants, is used to mean, now it gives us now the products that are being formed. The products now are being formed after the reaction. Now the sign, this is the arrow sign that we are saying is used to indicate the formation of a product. Now that's the sign that is used to indicate the formation of the product. Now after the reaction, which product is being formed? Now that's the sign that we use to see the kind of the product that has been formed. Now, using the equal sign instead of the arrow is wrong. Remember, equal sign is used in mathematics to mean after either addition, subtraction, division, or multiplication to give the summation of what has been done. But we are saying in chemistry that you using equal sign instead of an arrow is wrong. Names of starting substances like magnesium and oxygen in above example are written on the left side of the arrow, and these we are calling them reactants. The new substance produced by the chemical reaction are called products and are written on the right of the arrow sign. They are written on the right of the arrow sign. They are written on the right of the arrow sign. So that's how we write a chemical equation. That's how we write a chemical equation. That's how we write a chemical equation. That's how we come up with a chemical equation. So you're saying that it is wrong. It is not good to use an equal sign other than the arrow. It's not good to use an equal sign other than the arrow. So names of starting substances like magnesium and oxygen. Remember, we gave an example of magnesium reacting with oxygen. Now we are saying that now the magnesium and the oxygen are now the reactants. So they are written on the left of the arrow. On the left of the arrow. So we are calling them reactants. And the new substances produced by the chemical reaction are products and are written on the right side of the arrow. Now, after the reaction, now this the reaction that we have here. Magnesium reacting with oxygen. Magnesium reacting with oxygen. Now magnesium reacting with the oxygen here. So this is the reaction that we have. Here. Magnesium is reacting with oxygen to give magnesium oxide. It's reacting with oxygen to give magnesium oxide. Now we are saying that magnesium and oxygen, we are writing them on the left hand side of the arrow. So they are the reactants, magnesium and oxygen. Then we have an addition sign, meaning that magnesium is reacting with oxygen to form. So after their reaction, we have an arrow to mean what is being formed, to give us what is being formed, which is magnesium oxide. Now that's a word equation. But now we want to write this using the symbols. The symbols that we have symbols that we use to see to it that we are writing that chemical equation in symbol. Now the chemical equation have various notation that indicate the physical states and products. The physical states of the reactants and now the products. Now after writing the chemical equation, we also have the physical states of the reactants and the product. These notation are very important. In fact, whenever one writes an equation and misses to write them, the equation is not complete. So we are saying that for the equation to be complete, we have various notation that indicate the physical states of the reactants and the products. And we're saying that these notations are very important. In fact, whenever one writes an equation and misses to write them, the equation is not complete. Now, the physical states of the product and the reactants, they are always important. Now, these physical states or physical notation are written using also symbols. They have symbols that they are written using. So let's look at them. Let's look at the state symbols. Remember, we have different state symbols. So there are physical states of these either compounds or elements. So we have solid. They can either be solid, and we use an S to note solid. We have liquid. We use L to note liquid. We have aqueous. We use AQ. Remember, we always use this small letters of this. Then you have gas. We just use small g. Now, for solid, a solid can be a precipitate or a suspension. Liquid is a pure liquid like water, paraffin. Then you have aqueous is a solute or liquid dissolved in water. Then for the gas is a gas or vapor. It's gas or vapor. Now, here is what we are talking about. We are saying that we have solid. The representation of the state is S, small s. And we are saying that solid can be a precipitate, suspension, and etc. Then you have liquid. It's represented using a small l. You have a pure liquid like water, paraffin, and etc. So we have another physical state as aqueous. So there is a presentation of aqueous is AQ. Remember, we are using the small case of each. So it is a solute or a liquid dissolved in water. Then you have gas. Gas is represented using G. A gas or a vapor. So those are the physical states that each and every chemical equation will have. Each and chemical reaction will have for it to be complete. After now we have written the symbol. After having written the symbol of the reaction, the symbols of each element, the reactants and the products correctly, then we write the physical state of each, the reactants and the products. Then finally we come on balancing the chemical equation. Remember, a chemical equation has to be balanced. It has to be balanced. So, balancing chemical equation. So we have to balance the chemical equation in that the reactants and the products, the number of the atoms on each side are equal. So in order for an equation to describe a reaction accurately, the equation must be balanced. Remember, it must be balanced. Chemical reaction should always follow the law of conservation of mass, so that the total mass of reactants must be equal to the total mass of product. Total mass of reactant must be equal to total mass of the product. So you're saying in order for an equation to describe a reaction accurately, the equation must be balanced. So you're saying that the chemical reaction should always follow the law of conservation. Remember, here we are conserving the law of conservation of mass, so that the total mass of reactants must be equal. The total mass of reactants must be equal the total mass of products. Now, the product side and the reactant side, then total mass must be equal. That's when we'll say that the equation is balanced. That's when you say that the equation is balanced. Now you have here a simple diagram to show a simple diagram here to show the balancing. Now here, the reactants and the products are all equal. They are all equal. They are all equal. That's how our equation should be. That on both sides the mass is equal. That on the both sides the mass of the products and of the reactants are all equal. Let's consider our previous example that we had, the magnesium ribbon reacting with the oxygen. So we can write an initial equation containing the formula of the reactants and the products. Now here, we write it using the formula. We write it using the formula. We write using, so we are considering our example that we had last. Our example that we had last, our previous example of magnesium ribbon reacting with oxygen. So we can write an initial equation of containing the formula of the reactants and the products. Remember we say that after having written the word equation, now we are moving ahead so that we can write a chemical equation using symbols. Remember here we have Mg as our magnesium. Remember, I say the addition sign. We say that the addition sign means that the magnesium is reacting with oxygen. Now the arrow sign is giving us what is being formed. What is being formed. So you can see from our equation that we have the reactants and the product. Reactant and the product. Now the reactants, we say that the reactants are on the left side while the product is on the right side of the arrow. This equation is not balanced, as you can see. When we count the number of atoms on the reactants and the products, we can see that they are not what? They are not balanced. So as you can see, this equation is not balanced. So we want to count the number of atoms of the reactants and the products to see what we are saying. So this what you have when we count. This is what we'll have here. So for the reactants, we have one magnesium atom, as you can see that we have here one magnesium atom. Then we have two oxygen atoms. Then on the product side, you have one magnesium atom and one oxygen atom. One magnesium atom and one oxygen atom. So we want to balance them so that the number of magnesium atom on the reactant side is equal to the number of magnesium atoms on the product side. Same as to the number of oxygen. You can see that the magnesium are on the reactant it's one atom, and on the product side it's also one atom. But now, when you look at the number of atoms on the reactants for oxygen and on the product, they are not the same. So we want to balance to see that the left side and the right side are all equal. So as you can see that the left side, which the reactant, has two oxygen atoms, but the right side, which the product, has only one atom. It has only one atom. So from our drawing here, we can see that it is unbalanced. It is not balanced. You can see that now the left side is more heavier than the right side. Now the reactants are many. The mass for the reactants is too heavier compared to the mass for the product. Now our aim here is to see to it that we balance it. So an equation can be balanced using number of rules. So we have now a number of rules that we want to use so that to see to it that the equation is balanced. Now these are the same rules that you'll use even in other chemical, in writing other equations. So to see to it that all those reactions are what? All those chemical reactions are well written, well balanced, with symbols, with correct state symbols and correct formula, and also the symbol of the elements are also correct. Now here, our aim is now to see to it that everything is now balanced. Now we start with the rule number 1. Rule number 1, write the equation using correct formula for the reactants and the product. Now the rule number 1 that we have to take into consideration is that the correct formula of the reactants and the products. Correct formula of the reactants and the product. That's the rule number 1 that we have to adhere to. That's the rule number 1. That write the equation using correct formula for the reactants and the product. The formula has to be correct. The formula has to be correct. Now here we have the word equation that we had, and we have to ensure that from our word equation we have everything correct. Now we have magnesium. The formula for magnesium is Mg. We have the addition sign, which means that now magnesium reacts with oxygen to give magnesium oxide, and with this one all we are ensuring that they have correct formula. So you have magnesium Mg, and you have oxygen, then you have magnesium oxide. That's the rule number 1. That's the rule number 1, that we have to always ensure that the rule is adhered to. Now rule number 2, count the number of atoms of each element in the reactants and in the products, and check whether they are equal. So we are saying that rule number 2, we count. Now here what we do is that we count the number of atoms. We count the number of atoms of each element in the reactants and in the product, and then we check whether they are equal. Now that's the first thing. After having counted, now we check whether on the reactants and the products those number of atoms are equal. If those number are equal. So balancing number of atoms for each element in the reactants and product. Now let's balance the elements in the reactants and the product for the equation that we have of magnesium reacting with magnesium ribbon reacting with oxygen. Magnesium ribbon reacting with the oxygen. Magnesium ribbon reacting with the oxygen. Now we want to balance the number of atoms for each element in the reactants and in the product. Remember, we balance the number of atoms for each given element in the reaction that we have. So here we have atoms, that's the atoms of magnesium. Sorry, this is supposed to be small g, but not capital G. So we have atoms, those of magnesium, and those of oxygen. Now, on the reactant side, we are counting to see that we are seeing that on the reactant we have one magnesium atom, and on the product one magnesium atom. On the For the atoms of oxygen on the reactants, it is 2. For the product, it is 1. Now, you can see that the difference becomes in that of oxygen. So that's what we have to see to it that. So you notice the oxygen atoms are not equal. We have 2 atoms on the left and only 1 on the right. So after having noticed that, we move to rule number 3. After having noticed that, we move to rule number 3. Rule number 3, which will apply to make oxygen equal, to make oxygen atoms equal. Let's balance the equation by writing the number. We use the numbers in front of the formula. Remember that 1 is assumed to be there already. Remember that 1 is always assumed to be there already. Now, rule number 3. Rule number 3. To make we are now in the aim of making oxygen atoms equal. We are saying that to make oxygen atoms equal, we balance the equation by writing numbers in front of the formula. Now we remember that 1 is already there, so therefore we start by inserting 2. If this does not balance, we go to 3, 4 until the equation is balanced. So we are saying that usually we do not go to very big numbers. We just use small numbers. So to see to it that the equation is balanced. The equation is balanced. So that our equation is balanced. So you can see that when we put 2 before magnesium, it makes magnesium to have 2 atoms. Then 2 before magnesium oxide, it makes also magnesium to have 2 atoms. Then remember on the reactant side, oxygen had initially 2 atoms. Now on the product side, now oxygen now here it has also 2 atoms. Now it makes it to be balanced. We have 2 magnesium atoms on the reactant, 2 magnesium atoms on the product, 2 oxygen atoms on the reactants, 2 oxygen atoms on the product side. Now it makes our equation to be balanced. Now that makes our equation to be balanced. Makes our equation to be balanced. The number 2 now balances the equation. When you have 2 oxygen atoms, it means 2 oxygen molecules. The number in front of a formula means everything following is multiplied by that number. So we are only we only introduce 2 on magnesium oxide and on magnesium so that it is balanced. Then step 4, we count again the number of atoms of each element on the reactants and the product side. Note that all atoms are balanced. In our example here, all atoms are balanced. So after having done that, we can go ahead to see to it that if the atoms are balanced. So we say that before we count again the number of atoms of each element on the reactants and product side, we note that all atoms are now balanced. So we go ahead to count. We go ahead to count to confirm. Go ahead to count so that we confirm to see to it that what we are doing now is correct. Now we have here magnesium, you have 2 atoms on the reactants and on the product side. You have oxygen, you have 2 atoms on the reactants and product side. Now our equation is balanced. Our equation is what? Is balanced. You can see that our equation is fully balanced. Now step 5, we insert the correct state symbols. Correct state symbols. Remember we say that even if you write the correct formula of the products and the reactants, then when you balance but without the state symbols, our equation is our equation is incomplete. Now our step 5 is to insert the correct state symbols. Correct state symbols so that our equation becomes complete. Now we complete our equation by inserting the correct state symbols. Now magnesium is a solid, oxygen is a gas, magnesium oxide is solid. Now our equation is now complete. So using those steps we can balance any given equation. As long as you use everything that we have, every steps that we had, so if you follow it to the latter, so to see to it that the equation is balanced. Let's look at another example here of zinc granules reacting with dilute hydrochloric acid to produce aqueous zinc chloride and hydrogen gas. So we are reacting zinc granules with dilute hydrochloric acid to produce aqueous zinc chloride and hydrogen gas. Remember, we'll follow the steps. We'll follow our steps to see to it that so you have zinc granules react with dilute hydrochloric acid to produce aqueous zinc chloride and hydrogen gas. The first step is to write an initial equation using correct chemical formula of reactants and products. Using correct formula of the reactants and the products. Now here we have our equation. Where zinc reacting with hydrochloric acid gives zinc chloride and hydrogen. Now we write it in symbols. The symbol for the zinc is Zn. Hydrochloric acid is HCl. Then the product, we also have it. Now that is the first step. Now step 2, we say that we count the atoms, then we balance the number of atoms for each element in the reactants and products. In the reactants and the products. So step 2 is to count. Remember, we are counting the atoms. We count the atoms, then balance the number of atoms for each element in the reactants and the product. So now, after having written the correct formula, we now count to see the number of each element. And now here we have it that now the atoms of the zinc element, we have 1 on the reactants, we have 1 on the product. Hydrogen, we have 1 on the reactant, we have 2 on the product. Chlorine, we have 1. Sorry, here L has to be small l. Then here we have 1 chlorine atom on the reactants and 2 chlorine atoms on the product. So if you look at the reactants and the product, zinc is already balanced, but hydrogen and chlorine are not. So we need to have two hydrogen atoms. We need to have two hydrogen atoms and two chlorine atoms on the reactant side to see on the reactant side to see that they are all balanced. So this is something that you can note from there, that the zinc is already balanced. Zinc is already balanced. Now the thing that is not balanced is chlorine. Chlorine and the hydrogen atoms are not balanced. So we are saying that we need two of them. We need two to be on the left side, chlorine atoms to be two, and also oxygen and also hydrogen atoms to be two, so that it can also be balanced. Now this takes us to our step 3. We insert a number in front of the formula. In front of the formula. In front of the formula. In front of the formula to balance the equation. To balance the equation. Now that's our step 3. That is our step 3. We are saying that we insert a number in front of the formula to balance the equation. Now when we insert number to balance, this is what we will have here. This is what we will have here. You have zinc reacting with hydrochloric acid to give zinc chloride and hydrogen gas. Remember, we have inserted 2 in the formula of hydrochloric acid to make 2 atoms of hydrogen and 2 atoms of chlorine. So that also on the right side, you have 2 atoms of chlorine and 2 atoms of hydrogen. And 2 atoms of hydrogen. So you can note that the number 2 has been put in front of hydrochloric acid at the left side to make sure that the balance is achieved. The balance is achieved. So to confirm that, we have step 4. Confirm that, we have step 4 that we use to confirm. So we are saying that we know that the number 2 has been put in front of hydrochloric acid at the left side to make sure that the balance is achieved. Now we want to confirm, so let us confirm in the next step, where I say that our next step is step 4. Our step 4. Step 4, where we count the atoms again. Where we count the atoms again to count the atoms again to confirm if they are now balanced. If they are now balanced. So this is the confirmation of it. We have the number of atoms have zinc on the reactant, it is 1. On the product, it is 1. We have hydrogen, it is 2 on the reactants, 2 on the products. Chlorine is 2 on the reactants and 2 on the product. Now that confirms to us that it's now equal on both sides. Now the last step, which is 5, we insert the correct set symbol for each substance. Remember, we said that even if the entire equation is well written without the state symbol, we term it to be an incomplete. We term it to be incomplete. Now step 5, we are saying that we insert correct state symbol for each. Insert correct state symbol for each substance. For each substance. So here we have our equation with the symbols. We have zinc, which is solid. We have hydrochloric acid, which is aqueous. We have zinc chloride, aqueous. Then we have hydrogen gas, which is a gas. Hydrogen, which is a gas. So solid zinc reacts with dilute hydrochloric acid to form aqueous zinc chloride and hydrogen gas to form aqueous zinc chloride and hydrogen gas. Now, that's our correct formula that we have written. Correct symbol, correct state, and well-balanced equation. Now it makes it to be complete. Now this one makes our equation to be complete. That it is well written, bearing each and everything. It is well balanced. It has the state symbols. Now it makes our equation to be complete. Now, just following the 5 steps, we can write any chemical reaction given. We can write it and then balance it with all ease, because we just follow the steps that we are given. First, you have to ensure that you are having the correct symbol of the reacting substances, and then you have the correct product that is being formed. Then you balance it by counting the number of atoms of each element. Then if they are not equal, you start by inserting a number. You start with the small